Good afternoon, one and all. Myself, Dr. A. M. Takle, working as Associate Professor in Mechanical Engineering Department. Today, we will study descriptive testing methods, that is, tensile testing. We know that in metallurgy, there are two methods. One is a descriptive testing method, and another is a non-destructive testing method. In a distributive testing method, normally we are using this method to measure tensile test, compressive test, shear test, bending stress, impact stress, and hardness test. And second one is a non-destructive testing, in which we are normally use type penetration test, radiography test, ultrasonic test, etc. The difference between destructive testing and non-destructive testing is that in destructive testing, we are cutting the component, and in a non-destructive testing, we are measuring flaws without cutting the material. First, introduction, we will study the definition of tensile testing. In this lecture, we will study destructive testing, and one of the destructive testing is a tensile testing. Tensile testing is a mechanical test to determine a material's strength and ductility. Normally, this test is conducted to determine the mechanical properties like strength and ductility. Strength is nothing but ability to do resistance, and ductility is nothing but elongation. And to measure that strength and ductility, tensile test is performed. And purpose of this test to measure the material's ability to resist a tensile load. We know that when there is a tensile load, two poles are there. When a component subjected to tensile load, that is two poles are there, the material is measured against tensile load, and it is nothing but to measure the material ability to resist the tensile load. Tensile test is conducted. The various components required for tensile testing machine is or tensile testing machine is nothing but universal testing machine. One of the type of machine is a universal testing machine, in which we are testing tensile, compressive, shear, bending tests like that. And using this machine, we are performing tensile testing. Second one is a specimen. As per ASTM standard specimens are there, and using this specimen, the tensile test is performed. And third one is a extensometer. Extensometer is nothing but used to measure the ductility of the component. It is a small view of UTM machine, that is a universal testing machine, in which standard specimen is placed. Here standard specimen is placed. There are two jaw. One is a fixed jaw and second one is a movable jaw. And through that movable jaw, we are applying tensile load. It may be through hydraulic loading or it may be through servo loading. As per ASTM standard, specimen preparation is required. The dimension is important to measure the specimen, to prepare the specimen, that is measure length and cross sectional area. Because strength is nothing but load upon area, it mostly depends on area. So length and cross sectional area is important. Second thing is the surface finish. Ensure a small surface to avoid stress concentration. Smooth surface is required to avoid stress concentration, so surface finish is important. And third one is the notches. If required, introduce notches to study fracture behavior. Notches are provided to study that fracture or cutting behavior. This is the standard specimens. First one is having width 10 mm and thickness 3 mm. Second is having width 50 mm, thickness 5 mm. Third one is a width 15 mm and thickness 5 mm, and V notch is provided. This is as per ASTM standard. The various specimens are prepared. The procedure, the procedure for tensile testing is mounting. First one is a mounting. I already told in the diagram that mounting is there, in which two jaws are there. One is a fixed jaw, and through second jaw we are applying the tensile load. Mounting. Secure the specimen in the grips of the testing machine. To that testing machine or UTM machine, grips are there. So secure, the specimen must be gripped on the testing machine. Second one is the load application. Gradually increase the load at the controlled rate. Load is increased gradually. Suddenly load is not applied. Load is increased gradually, that is step by step, up to that fracture of the material. So gradually increase the load at controlled rate. Third one is the data collection. Record data and corresponding elongation. We have to record the data of load, then its tensile strength, and also corresponding elongation, that is strain. How much that component is elongated. Then very important factor is the stress strain curve. Stress is nothing but load upon area and strain is nothing but change in length dividing by original length. The definition of stress strain curve is a graphical representation of stress, that is load upon area, versus strain, that is change in length dividing by original length. Again I will repeat, stress is nothing but load upon area and strain is nothing but change in length to the original length. So through that stress and strain curve is plotted. Regions. There are various regions in a UTM machine during the tensile testing, and first one region is a elastic region. Material returns to its original shape when the load is removed. Once the load is removed, the material comes to the original shape, is called as an elastic region. Then yield point, the point where plastic deformation begins. For brittle material, there is no any yield point, directly ultimate load is there, but in case of ductile material like steel, there is a yield point is there because it is elongated, and the yield point is nothing but the point where plastic deformation begins. That is, plastic deformation starts. Third one is the plastic region, material deformations permanently. Plastic region is nothing but in which material deforms permanently. Permanent deformation is there. Next one is the ultimate tensile strength, that is UTS, maximum stress before fracture. That ultimate tensile strength is nothing but maximum stress, that is ultimate stress before fracture, means material will fracture means completely breaks, and that stress is nothing but ultimate stress, or that strength is nothing but ultimate strength. The ultimate strength is nothing but again maximum stress before fracture. At that stress the component will fail, and normally for brittle material that ultimate tensile strength is taken into account for designing material. The next point is the necking. Necking is nothing but localized reduction in cross-sectional area. That is cross-sectional area. Reduction in cross-sectional area means when we are applying two pulls, the cross-section is reduced because of that two pulls are there, and that procedure is called as a necking. And fracture. I already told that tensile testing is a destructive testing in which fracture takes place. That is, we are completely breaking this component, and fracture is nothing but complete separation of the material, means completely breaking of the material. This is the diagram for stress and strain curve, in which elastic limit is there, yield strength is there, and after that plastic region is there, and at the end of plastic deformation where fracture is there, that strength is called as a ultimate strength. Second important point in a tensile loading is a ductility. Ductility is nothing but it is the ability of material to fracture or plastically deform without fracture. Definition of ductility: the ability of a material to deform plastically without fracturing. Yeah, I already told that in a tensile machine, one yield point is there, that is elastic deformation, and after that plastic deformation is starting. And ductility is nothing but the ability of material to deform plastically without fracturing. Means the material is plastically deformed without fracturing is nothing but ductility. Measures. The ductility is measured with the help of following points. Permanent deformation or permanent elongation or permanent ductility is nothing but final length minus original length dividing by original length into 100. And percent reduction in area is nothing but original area minus final area dividing by original area into 100. With the help of these two, ductility or elongation is measured. So next important point in a tensile machine is a modulus of elasticity, that is E. Definition. Definition: a measures of material stiffness. Modulus of elasticity or modulus of rigidity is nothing but it measures the stiffness of material. Calculation: slope of elastic proportion of stress strain curve. Through that stress strain curve, that slope of that elastic proportion of stress strain curve measures the modulus of elasticity, that is the Young's modulus. Various applications of tensile testing. Tensile testing is very important because a design engineer wants the ready-made tensile strength of material, and which is given in the design data book. The various application of tensile testing is a material selection, and normally material selection is a part of design engineer in any organization, and that material selection choosing appropriate material for specific application. We have to choose particular material for particular application. Then next one is a quality control. Ensuring product consistency means we are designing that component through that tensile load. So quality control is a very important part for ensuring product consistency. Also it is used in application is a research and development. Studying the material behavior and developing new material. Now it's the research and development. We are studying the material behavior, that is its already discussed is a tensile strain, its elongation, its modulus of elasticity. We can be studied, and through this material study, we can develop new material, and for that new material, again research and development is there, and we can again measure the properties for that particular material. Conclusion of this lecture is summary. Tensile testing is a crucial tool for understanding material properties. To understand various material properties, that tensile testing is very important because already told that a design engineer wants tensile strength of the material to calculate various dimension or to give the shape and size of the particular component. So that tensile testing is very useful to find the material properties. Importance: it provides valuable information for design, manufacturing, and research. Already told that it is very important for design engineering, manufacturing engineering, and some research purpose also. So, second conclusion is importance, and it provides a valuable information for design, manufacturing, and research purpose. And thank you. And at the end, it is clear that tensile testing is very important to design, manufacturing, and for research work. Thank you.